Assalamu alaikum and good afternoon. The project about designing a smart door with a smart tourism ecosystem. I will talk about the problem statement, how to designing a smart door to reduce the risk of COVID-19 transmission in tourism hotspot. And objective number one, designing a system to sense the temperature and distance between the IR, the thermometer, and the tourist forehead. Fever is one of the COVID-19 symptom. Number two, designing a system to connect the number of tourists inside the premise, practice social distancing. Number three, designing a system to activate the motor actuated door at the entrance depends on the body temperature of the tourist, number of tourists inside the premise, and the travel history of the tourist. This is for example the flowchart. A digital thermometer connect with A and the result value 37.5 connect with B, and approximately senior connect with added and pressure senior A and pressure senior B connect with counter, and counter connect with A, and result value A connect with B. Designing sensing drive. The purpose of using the thermometer is to measure the temperature of the tourist before entering the premise. Number two, the proximity senior is used detecting the distance between the visitor forehead and temperature senior and the temperature senior. Number three, the purpose senior is to detect the visitor enter and exit, and the database is used to address visitor travel history model using switch. This is the circuit designing circuit. Magnitude digital compare is a conversational circuit that compares to digital or binary number in order to find out whether one binary number is equal less than on greater than the other binary number. You logically designing a circuit for which we will have two inputs, one for A and the other for B, and have their output, one for A B condition, one for A equal B condition, and one for A B condition, and use it to compare to bit is collect a signal bit compare. It consists of two input, each for two signal bit number, and their output to generator less than equal to and greater the between two binary number, and used to compare two binary number. Each of 2 bit is called at a 2-bit magnitude compare, and it consists of 4 inputs and their outputs to generator list, then equal to and greater than between two binary number. Thank you.
I will continue with the presentation of Group 11. Okay. The main ICs used in the counter is 74HC190 and 74HC85. The 70HC190 is an up-down counter, and the 74HC85 is a 4-bit comparator. The pressure sensor is modeled by SPDT switch. The switch output high when the tourist step on it. The output of the SPDT switch is passed through an edge detector circuit. The reason will be explained later. The XOR gate takes the input from the pressure sensor and the output to the clock of the IC. This is to ensure that the counter does not count when both inputs are high. LED 1 to 4 represent the number of tourists inside the premise in binary. The output of the counter is connected to a 4-bit comparator. If the number of tourists is more than 8, no more tourists are allowed to enter. The PR is the output to the connected to other circuit. Now I will start the live demonstration. If the entrance is press 5 times. The tourist is still allowed to enter as shown by LED 5. The LED 5 is the blue color. If the tourist is exit from the premise, modeled by the exit switch, 3 tourists have exit, so we left with 2 tourists inside the premise. As you can see, just now I purposely left the entrance switch high, but the exit switch can still function properly. This is thanks to the edge detector circuit. After that, if more tourists is entered into the premise, the preset value is 8. So LED 6 will light up red color, which means the system does not allow any more tourists to enter until some tourists exit. Second, we have the final circuit. The previous output T out from the temperature sensing circuit, P out from the counter, and a new output from the database. The database of message charger is modeled by a switch. The switch is high if the tourist does not visit COVID-19 hotspot for the past 2 weeks. The door will activate if all the 3 criteria is met. The door will not activate if any of the criteria is not met. Now we move on with the conclusion. The system is able to sense the temperature at an appropriate distance. Tourists having body temperature equals or greater than 37.5 degree are not allowed to enter. And the system is able to count total number of tourists inside the premise. A controlled number of the tourists inside premise allow tourists to practice social distancing. The system will activate the motor actuated door at the entrance and the tourist based on body temperature, number of tourists inside, and the premise and travel history criteria. This is the end of our presenting. Thank you.
Okay, thank you, Yara and Jianshen. Next, we move to group 3, Daniel and Danish. Please. Divesh. How come I got the wrong name here? So Divesh, Daniel and Divesh. Okay, please.
Afternoon, sir. Good afternoon, sir. My name is Daniel. We're along with Divesh. We are group 3. Can you hear my voice?
Yes, please proceed.
All right. Right. So, for group 3, this is the design for our COVID-19 bus checkpoint. I will be the presenter first for the first part. Divesh, next, please. Divesh, next. Hold on a second. Sorry, sir. Divesh.
Hello. Can you hear me?
Oh, wait.
Yes.
Okay. Just a second. I have done. Daniel, can you see the second slide?
No, I can't. I really can't. I think I'll share my. Mine's lah. If that's fine lah. See, you're not. I can't see the next slide. Wow, this is. 1 second.
1 second, sir. Sorry. Yeah, let me share. I think now I think. Yeah.
Okay.
Can you see it right now?
Nope. Still first slide.
See first slide.
Can be lah. Oh.
Yeah, you should start the session.
Yeah, plan B. 2 seconds. Okay. Okay. Wait. All right. Can you see? One. Is it? Oh. I can't. Okay, never mind lah. You can see it, right?
No, I can't.
Right. I'm at the second slide right now. No. Wait. Okay. How about this? Nothing.
Nothing.
Okay. Can see the image but can't see yours. Oh, okay.
Can you see now?
Yes, we can see
Loading.
Daniel, I think only
no,
for you
I-
we can.
Okay, fine, whatever. What slide is this right now? Right, might as well I'll just what. All right, I'll just present that. Never mind. Okay, so anyway, that's okay. Anyway, so for our project motivation, the reason why we decided to design this bus checkpoint, this bus COVID-19 checkpoint, was the fact that as of this moment, buses are allowed to operate with full capacity of the passengers. And there's always tend to be an overcrowding in buses and public transport, and there is a lack of SOP within it. As we know, COVID-19 can be spread among airtight enclosed space, and buses are one of them. So therefore, with the checkpoint, the purpose of it is to design a somewhat soft reminder that would alert the passengers of the fact that the COVID-19 is still there. It's basically a soft reminder of the pandemic. Not only that, we're hoping that this would be somewhat. Not only that, we're hoping that this system would be somewhat serve as a foundation, for an SOP for any contagious disease besides the COVID-19. Next, Divesh. Next. All right. So
Yeah.
methodology. One of the key features we thought of designing for our bus COVID-19 checkpoint is that we decided to have an alarm that would signify that either the passenger going in has a Thai temperature, sick human temperature of 37.5 Celsius, and that the bus when it exceeded the capacity set, which in our case, that would be 21. If there's 21 or more passengers detected within the bus, the door will automatically shut. And not only that, we have just basically included a manual override for bus owners in the event they decided to shut down the alarms or to allow the bus doors to operate as normal. Which means that while the counter, our system still would record the number of passengers, but there will not be the alarm or the automatically shutting off our bus door, which will make it probably a better idea in the event of after the pandemic, when it's no longer required for us to adhere to our SOPs. Then we basically created a circuit in our Simulide, and then we run the simulation. Next, Divesh. The chart of our idea is that once the passenger goes in and gets scanned through the thermometer first. If the thermometer detects above 37.5 Celsius, the alarm will go off. We basically use a little bit of our analog knowledge in it. If it's below 37.5, which is the healthy body range, then it will go through a motion detector, which the system will record there is one passenger inside the bus. More than 21, the alarm goes off and the bus door will close automatically. In the event the passenger goes off, they will go through another motion detector, separate. There will be two motion detectors, which we will show you later on. And then the counter will just minus the number of passengers in the bus will be just -1 in the bus.
Okay, I'll be continuing from here. I'm Divesh, and this is the full display of the circuit, our circuit. There's 5 parts of it. The first one, temperature sensor, and the motion detectors, and the counters, the alarm system, and the display part right here. So the first one, I will go to the temperature sensor. And temperature changes its resistance values based on the temperature detected. If a person's body temperature is high, the thermistor will go low and the alarm will go off. So if a person body temperature is low, then thermistor will be high and the counter will start counting. And the second part is the sensors. There's 2 sensors we have used. The first one at the entrance door and the another one at the exit door. As if a person enters the bus door, it will sense 1, and with the end gate here, if the person body temperature is low, with this the counter will be start counting 1 as a person entering, and it will continue as the passengers are coming into the bus. So if passengers are getting down from the bus, the sensor at the exit gate will be activated and the counter will be counting downwards. And this is the counter circuit, which will count from 0 to 20. And this is the alarm system, where the alarm goes off if a person body temperature is high, and also when the maximum limit is reached, which is more than 20. And this is the 7-segment display. The display, it will be displayed from 0, 1, 2 until 20. And I'll be sharing the circuit right now for a while, doctor. This circuit display. Okay, first I'll run the circuit first. As you can see, if a person body temperature is low, the thermistor resistance will be high. The resistance will be high, and with the sensor at the entrance gate detector 1, the counter will be start counting. Sorry. Wait a minute. I set up. As it's detecting, the display will be start running. Wait a minute, sir. I think my computer is jamming. Sorry, sir. As I say, if the temperature is detected, the resistance thermistor resistor is high, and the entrance gate is detector 1, the counter will start counting. Sorry, my laptop is currently running really slow, and the display is not showing really well. I will show in the another video. Sorry. And as it is, see, people are entering into the bus. As you can see, the counter is counting. My computer is quite slow right now. It's jamming. Sorry. And if people are the at the exit gate will be activated, and the sensor at the entrance will be deactivated. And with this, people will be leaving the bus, and the counter will be counting downwards. As you can see here, it will be going from 5 to 4, 3 to 1 until 0, because people are leaving from the bus. Okay, I'll get back to the temperature part. Temperature is high. So if a person body temperature high, which is more than 37.5 degrees Celsius, the thermistor will detect and the resistance will go low. With this, the alarm goes off because it will detect person body temperature is high. With this, you can see here, right here. Sorry. Sorry. Sorry, my computer is jamming. Sorry, I'll get back to the circuit. As a person body temperature is high, the thermistor will go low. Go low, the alarm will go off. As you can see here, the alarm will go and will alert the driver. So the person with the high temperature will not enter into the bus. And also, there's also a system alarm to goes off if it reaches the maximum limit. So I increase it right now, and the counter is counting. Okay, sorry sir, I continue. As you can see, the counter start counting. When it reaches the 21, the alarm will also go on because it reaches the maximum limit of the circuit, and will alert the driver. So the driver will not let anyone enter into the bus which is more than 21 to keep the social distance. So I'll wait until it reaches 20, then I will explain it. So you can see the second display is we start displaying, which is 10 and 11 and so on. Again, I'm telling sorry because my laptop is really cannot use right now. Fifteen. And it's 19, and the maximum limit is the 20. And after the 20, the alarm will goes on. As you can on at is 20, this is the maximum. After this, the alarm will go on. I'll pause it. As you can see here, the alarm when it exists, the alarm will go on and will alert the driver. And also when achieves the maximum limit, the entrance door will be automatically closed. As you can see here, the probe just showing from 0 to 5 and the entrance door will be automatically closed. And that's all from me. Closing and get back to Daniel to continue the slides. Continue.
Yeah. Okay. All right. Thank you, Vivesh. So for our future work, we like to suggest that the fact we need to consider finding a way to detect infrared sensor and to able to able to transfer the temperature to that thermostat, because we're supposed to be able to detect the temperature from a little bit distance away, and to maybe figure out how we can implement it along with our current bus door motor. The challenges, aside from the 7 segments, because due to the fact it's 5 bits, have to draw a K-map. The simulation will also have an error when the potentiometer in our simulation reaches 15 kilo ohms. Next division. So in a conclusion, we have finally able to create the circuit that would otherwise fulfill all our objectives, and we learned a lot during this FGPA. That will be all. Thank you for your time. That's it.
Okay, thank you, Daniel and Divesh. So next up, Group 16, Wei Wen and Sok Hui, please.
Hello, can you all see my screen now?
Yes.
Okay. So good evening, Doctor. We are from Group 16, and the project that we would like to present is Contactless Delivery Smart Locker. Due to the COVID-19 outbreak, all citizens are required to stay at home and avoid close contact with others. During this pandemic, more people start buying things online rather than buying things from a physical store. The demand for food and home delivery service surges. People need to go out to retrieve deliveries from the delivery man, and this may risk their health, especially for those who stay at high densities and crowded residential areas such as apartments and condominiums. Therefore, in order to overcome these problems, we came out of an idea, which is by making a contactless delivery smart locker system. Our objective is to design and fabricate a delivery system to reduce direct or physical contact, to reduce the chances of people going out to retrieve deliveries, provide a safe delivery system in high density and crowded residential areas such as apartments or condominiums, and develop a locker system that can secure and lock the doors and allow access to the recipients through PIN code. In this system, delivery men can deliver items to the residents without physical contact. Besides, the smart locker can automatically lock the delivered items that store in it to prevent the items from getting lost. Residents can retrieve their items at any time without afraid of it being lost. This smart locker system uses key codes to provide easy access to the users, in which the users can collect the delivery items by keying in the correct PIN code. The locker won't open if wrong PIN code is keyed in. It safeguards the parcel and delivered item if residents couldn't retrieve it immediately. Next, the software that we use to build the system are Arduino IDE, Proteus, and SketchUp. Arduino IDE is used to write the coding for the system, whereas Proteus is used to design the schematic and simulation of the circuit, while SketchUp is used to draw out the design of the smart locker. For the hardware part, we use Arduino microcontroller, infrared sensor, LED, LCD display, servo, buzzer, keypad, button, resistor, and BJT. And these are the designs of our smart locker, which drawn by using SketchUp. In the compartment, there will be an IR sensor to detect whether the compartment is empty or being occupied. And there will be a LED on the compartment door, and it will light up if there is something inside the compartment. And these slides show the process flow of our system. When the system starts to run, it will first display a welcoming message. The system will ask user to choose the compartment number. When the button of choosing compartment is pressed, the LCD display will show the compartment of number chosen. If the compartment is empty, the LED on the compartment door will remain off. Then, the delivery man will enter the residential number and compartment door will open. The door is closed after putting in the item. The LED on the compartment doors lights up now. If the compartment that have been occupied is chosen, the LED on the compartment door is on. Residents need to enter correct PIN number to open the door. The door is closed after taking out the item, and the LED is off now. If wrong PIN number is given for 3 times, the LCD displays will show a warning message and the buzzer will sound. The system will be off, and I'll pass it to my partner Wei Wen now.
Okay. Can you hear my voice?
Yeah, I can.
Okay. I'm the Raven and I'll be continuing the slide. So as for the electronic circuit development, we will have a LCD display to display the instructions and outcomes of the action. And then the keypad is to enter the code and will be displayed on the LCD display. And then there's a servo, which is used to represent the locking mechanism of the door. And to make it clearer, there are two LEDs, in which one representing the door closing and another representing the door open. And then there are two buttons, in which one is the reset system, is to reset the system, and another represents the selection of a compartment. And then we have the IR sensor, and it's connected to a test pin to indicate the detection of an item in the compartment, and LED light will react with the sensor. So when the test pin is put as 1, the LED will light up, and then when the test pin is put as 0, the LED will turn off. And then we have a BJT transistor connected to the buzzer to create an oscillation for the buzzer to vibrate and produce sound. It also acts as the switch for the buzzer. So next slide. The system will depend on the IR sensor. So when the sensor does not detect anything in the compartment, whoever selects the compartment will be the delivery man. And when the sensor detects there is something in the compartment, whoever selects the compartment will be the resident who ordered the delivery. So when we start our simulation, welcome sign will show, and please choose a compartment. This button represents one of the compartment, and it is number 34. So since the compartment is empty and the light is not on, so the delivery man will be putting in the residential number of the client, and then the door will open. So here it shows empty because the IR sensor does not detect anything in the compartment, and you can see the light is off. So the delivery man will put in the item into the compartment, and then the light will be on and item detected will be shown. So to close the door, we use number 5 on keypad to simulate the door closing. And then it will show, please choose a compartment again. So when we select the compartment, it will show enter pin number. So now the resident will enter the correct pin number. So when it is correct, the door will open. And then as you can see, the servo here, it rotates. So it represents that the door is unlocked. So since the item is detected and the light is on, and then the resident will need to take out the item. After taking out the item, it will show empty and the light will be turned off. So, close the door. Okay, and then please choose a compartment again. So let's say another delivery man come to deliver another item to another resident, and then the compartment is selected and enter another residential number of another house. And then the door will be open. So it's empty, delivery man will put in the item and close back the door. So now the resident will need to select the compartment and key in the number. So when it's wrong, it will show wrong code and will ask us to choose the compartment again. So it is still a wrong code. So this is the third time to key the pin number. So when 3 times wrong pin number is keyed in, it will show a warning sign and the buzzer will be activated. And also the system will be turned off. So to start back our system, we use the reset button. Okay. Okay, so as for the challenges we face, sometimes the simulation will run slow and has a little delay. For example, the IR sensor. When the test pin is changed from high to low, the light does not turn off immediately and has delay. So this can be caused by the hard drive of the computer is too busy, or can be caused by the looping or congestion of the code. So to solve that, we will need to close off other windows when running the Proteus software to minimize the delay. Also to ensure that the coding does not loop too many functions multiple times unnecessarily, which will cause the system to slow down. And another challenge we face is the program of the system can be very confusing when synchronizing all the functions of the components together, especially the password system using the keypad. So to solve that, we do many different stages by adding each component one by one, so that there is problem in the new stage. When there is a problem in the new stage, we can go back to the old one to troubleshoot without doing it all over again. As for the password, we will store one number in an array and concatenate all the 4 numbers into a string so that it is easier to check instead of checking it one number by one number in a loop. Okay, as for the limitations, the locker could not contain food for a very long time, and also the IR sensor might not be accurate as it will detect anything in the compartment, which might not be the delivered items. And next slide. So as for the future works, we can add wireless notification features in which it can automatically notify the residents when the item is delivered. And also we can add more sensors such as motion sensor, which will turn on the system when it detects an incoming person and turn off when there is no one near the locker. And then the night lights, in which it will light up when the area is dark or during nighttime. Also adding timer or alarm to notify when the door is not closed for a certain amount of time. And then lastly, adding more compartments in which one system can manage more than one compartments instead of only one. And next slide. Okay, and that's all from us, and thank you.
Thank you, Wei-Wen and Sok Hui. So next, we move to Group 19, Kai Leng and Pen Yuan.
Good evening, Doctor. We are from Group 19. Our group project design is the body temperature detector smart door system. Starting from the objective of the project is to be able to design a system that can measure the temperature of the person, to reduce close contact with the people, and also to detect the sign of infection of that person. All the objective above is in this project has been achieved. These are the few problem statements that we have to identify during our simulation process. All the problems will be covered later. In the motivation of our project is that we hope to design a system that could function by itself without a person to monitor or controlling it. Besides, during the pandemic COVID-19 right now, people having fever is dangerous and could be the carrier of the coronavirus. So the smart door could help to prevent a fever person to enter places. This is the prototype of our conceptual design, which are being designed using SolidWorks software. The height is to be designed at 200 cm times 50 cm in width to allow only one person passing through it, as it can only detect one person at a time. The material we plan to use is stainless steel 304 grating, which are strong and non-rusting. In this project, the circuit that we plan to design is to be able to detect the body temperature. So when a person walking near to the temperature detector smart door, the system will be automatically active and start functioning. The system starts to detect the temperature and send the data to Arduino to process and display on the screen. When the body temperature is higher than a preset temperature or normal body temperature, the alarm will be triggered and ring. So next, Kai Lun will present.
Good morning, Doctor. My name is Kylon. This is the component that we use in our project, which is Arduino Uno, infrared temperature sensor, buzzer, resistor, LED, LCD display, and infrared obstacle sensor. Next. This is our design circuit, which set up with the component in the previous slide. Next. Then I will play the video documentation of my simulate part. Pangin. No sound. I will present for the project. Firstly, set up the circuit as in my simulation and run it. Firstly, the infrared obstacle sensor will start to detect the people, then has a test pin to represent the presence of people. When the logic state of test pin is 0, all components in the circuit will not function except blue LED. The blue LED will show high output, means that the system will be temporarily down and will in the saver mode to consume less electricity. When the logic state of test pin is turned to 1, the temperature will start to detect the temperature and send the data to the microprocessor to transfer data, calculating data, and the data is sent again to the LCD display. The LCD display will show the output of the result of the temperature value detected by temperature sensor. When the body temperature detected by temperature sensor is lower than normal body temperature, which is 37.6 degrees, only green LED will be light, show that the people is normal condition. The temperature sensor, we assume that another condition, which is the body temperature detected by the people is higher than normal body temperature. The red LED will be light up and the buzzer will produce loud sound, so that the people could be a carrier of coronavirus. Next. As a conclusion, the circuit implementation and result testing is successfully. As the improvement, we will upgrade it to decrease the delay of a system so that allowing a person to walk through without stopping his step. Next, more future design. A better design to allow people to build the screen in more convenient way and using environmental friendly material to build the door. Next. That's all for our group presentation. Thank you.
Okay, thank you, Kylan and Penyuan. Next, we move to group 18, Ziheng and Yilang, please.
Can you hear me?
Yes.
Okay. Good afternoon, Doctor. We are from Group 15, and our title is about the smart tourism, that is the crowd controller. Next. This one is our content of our presentation. Next. Our objective is to design a system that would count the number of people and also control the flow of people into the premise through a controlling system. Next. The motivation is this crowd controller project is important in preventing the premise being overcrowded and the social distance could not being practiced in the place. Our project would reduce the number of persons entering the premise through passively by enable and or disable the promotional banner in attracting or not attracting the crowd, and also actively by preventing them from entering the premise when it is full capacity. Next. The methodology of our circuit design is literature review, then we go into the conceptual design, and we go into the prototype. After prototype, we start to design our circuit and testing our circuit. Next. The item used for the hardware is the infrared sensor, LCD display, buzzer, LED light, the sliding door, actuators, and we use the software is Multisim. Next. This slide I will going to pass to my groupmate, Yang.
Very good morning. Very good morning, everybody. My name is Tommy Young, and now I will discuss about the design architecture of our group. First, as you all see, our circuit for the people counter, which act as the brain of our system, and the potentiometer is actually connected to the sensor to the sensor that will detect people passing through or leaving into the place or leaving the place, in which it will increase by 1% for 1% for every person entering the premise, and decrease by 1% for every person leaving the premise. And the LED light is actually a logic. It's kind of like acting as a logic gate condition. So when the LED condition is activated, it means that in this op-amp comparator, there is something there's voltage passing through, which will be connected to the rest of our circuit except the exit gate. So there's two conditions we set up, which setup is LED1 and represented by LED2. Next is our entrance gate. So in a normal condition, when the entrance gate sensor detects somebody, the circuit will be closed, and the enter gate actuator LED will be activated, which means that the gate will open to allow entrance. And if our preset condition, which is condition 2, is activated, which means the premise is full, then the circuit wouldn't the LED and the entrance gate sensor is closed, the entrance gate actuator will not be activated, but rather the buzzer at the LCD display to tell them the place is full will be activated. The exit gate is just a normal gate where when the infrared sensor detects somebody, it will just close and allow people to the gate open and allow people to get out. The promotional banner is when it's under condition 1. After condition 1 is activated or condition 2, the promotional banner would be closed to passively not attracting the attention of others toward our premise. Now this is a demonstration of our circuit. Thank you. Okay. Sorry. Do you guys hear anything?
No.
Oh.
Nothing.
Wait. I think if like that, then I will get another thing. Share another. Oh, oh, okay. Wait, oops, sorry.
Hello everyone. Today
is
I
there
want
anything
to
else?
explain about the project my groups, that is the crowd controller. First, I would like to mention about the voltage switch 1, voltage switch 2, and voltage switch 3. They are used for the opening and closing the function of each part of the system.
Yes, we can hear.
First, we look at the above.
Okay, sorry.
The two potentiometer act as a people counter, and the percentage is represent the number of people. Both potentiometer will decrease and increase simultaneously when there is people going out or going in from to a place. The LED1 and LED2 are only for the reference for the constructors, so they have no functions. In this case, we already set the maximum number of people to 50. Now we look at the promo banner, promo sign, and map indicator parts. In this part, we set them to be function when the people are below 30 because they are used for attract the visitors. So we can see when the number is below 30, then they will light up. And when the number is above 30, they will not light up. Okay. Now we go to the next part, the entrance part. This entrance gate sensor is used to detect when a visitor is come near to the gate, then this sensor will be closed. And when there is no people around or near the gates, the sensor will be open. Okay, so now we look at the number. Okay, since the number are not exceeds the maximum, so what will happen to the gate? That is, when people come near to the gates will be activated and opens to let them go inside. And if our number exceeds the maximum, that is become 51 people, then if people come near to the gates, the entrance gate will not be activated and the visitor cannot go in. Besides, the buzzer is activated and they will display no entry. And now we go to the exit gate. Exit gate sensor is same as the entrance gate sensor. When people came near to the gates, the exit gate will be activated and the visitors can go out from a place. Wow, when there is no people around, then the exit gates will be as open circuits. So the gate will not open or close.
Um, so the result is from our circuit is that when the number of visitor is less than 30, which means the potential meter is less than 30%, the promotional banner equipment and the entrance gate will be functioning as usual. When the number of visitor is around 30 to 50%, in which potential meter is in 30% or till 50%, the promotional equipment will be disabled and but the entrance gate will still be functioning as usual. And when the number of visitor is more than 50, means the place is full and potential meter resistance value is more than 50%, the promotional equipment and the entrance gate will be disabled. And when somebody is nearing the infrared sensor, the buzzer and LCD display no entry sign will be activated. Yes. And to the implementation challenge is that when designing the circuit, our greater challenge is the people counter. As a flip-flop circuit is not that able to increase and decrease its logic value freely, while an adder circuit is not able to trade a continuous counting, we have met some issue with the stimulation of a people counter. But thankfully, we somehow stumble upon a op-amp comparator circuit that is controlled by potential meter that we could modify. So the improvement and future work, first of all, is we are thinking of integrating more usable function to passively divert the crowd and integrating the system in a larger scale with big data to control the movement of the crowd more effectively. And the third one is to improve the infrared sensor as we know that the infrared sensor may have an accuracy in detecting a human or a disabled human, mean that they are wheelchair or kind of having a very not so normal human like and and a normal human. So in conclusion, the crowd controller we designed can aid in controlling the flow of the people in a premise and reduce the spread of COVID-19 through preventing close contact. In overall, the objective of this mini project is achieved. Thank you.
Okay, thank you, Ziheng and Yi Yang. Next, we move to group 7, Zianji and Shazwan. Please.
Hello, can you hear me? See my screen?
Yes.
Oh, all right. Thank you. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. I bid to Dr. Wan Amir and also my fellow friends. So, our project title is Smart Device for Mobility and Transportation. Okay, will be our content for our presentation. So, the problem statement is, Malaysia app doesn't cost access to smartphone. This is inconvenient for kids and senior citizens. Plus, this is designed to control the people in the station, in the public transport station. And plus, social distancing in public areas like public transportation station is hard to be implemented. So it needs a bit better digital unmanned system in public transportation stations, as it said, point to reduce human interaction and contact. So our proposed solution is to design a smart device for mobility transportation, which consists of three main features. The first one is social distancing alarm. The second one is the RFID tag for data collection and contact tracing purposes. And the third one is the COVID-19 checkpoint and public transportation station at the entrance to limit the capacity in a station. So our objective is to design a social distancing devices that utilizes a PIR sensor and ultrasonic sensor to design a RFID device that could ease and speed up the data collection for contact tracing purposes, and also to design a counter that will supervise the passenger movement at the entrance of the station to limit the number of passengers in the station. So this will be our flow chart, how our system is going to work. I'm sorry if it is too small. The first one at the start, then people with smart device get into the public transportation station. Then it goes to the symptom checks, which is the body temperature. As the temperature exceeds 37.5 degrees Celsius, then the gate will not open and it will end. But if the temperature is less than 37.5 degrees Celsius, it will go to the capacity limit check. And if the limit in the public transportation has exceeded, the gate will not open. But if it's not exceeded, the gate will open. Then at the gate there will be a RFID tag for data collection. And then in the station, the social distancing alarm will keep the appropriate distance between the passengers. Then it will end. So this secret design for the social distancing alarm. I combine how usually the street lamp used to work. But street lamp, the R4 usually will be the LDR, but I changed it to the 74LS08 IC, which is in gate. So it means that when the V1 is higher than V2, then this LED will not light up. LED represents the buzzer. I changed the LED to the buzzer for simulation purposes. So, but if V1 is lower than V2, it means that V1 will be higher than V2 if the output on the PIR sensor and ultrasonic sensor is 0. So this V1 will be infinity. So that's why LED will not light up. But if V1 is lower than V2, it means that it will flow when the output is 1, then the current will flow. So V1 will be lower than V2, then LED will light up. I will show it through my simulation. So as we can see here, when the PIR sensor, on the PIR sensor is 1, the LED will not light up. But if the ultrasonic sensor is 1, the LED will not light up. But if both of the PIR and ultrasonic sensor is 1, then it will light up. Okay. So this is my prototype. I use Arduino Uno, the ultrasonic sensor, PIR sensor, IC74LS08 here. The 2N3904 transistor here is quite small, LED and 9-volt battery. So this is simulation of my prototype. For the real implementation, we need to set the ultrasonic sensor to have a distance that will detect that will be output 1 if it is the distance is within the 1 meter range. But for the only for the demonstration purposes, I changed it to 20 centimeters range only, because so it will not take too much space. So as we can see here, if my hand is within the 20 centimeter range, the LED will light up. So as you can see here, the bottle is within 20 centimeter range, but it is not a human being, so it will not be detected. So this specification is really important to differentiate between human and also another objects. That's why I combine the PIR sensor and ultrasonic sensor. That is what PIR sensor is used for. So as you can see here, if it's out of range, 20 centimeter range, it will not light up. The LED will light up. But if I get my hands closer, then the LED will light up. And if I get it out of range back, then it will not light up. Okay, this is the result. PIR sensor 0, 0, 0, output 0. This 1, 0, 0, 0, 1, 0. And if 1, 1, the output will be 1. Okay, so for the next is RFID data collection system. This is the circuit design. I use Arduino Uno, RFID tag, RFID RC, and RFID RC522. So this is simulation of my RFID. As you can see here, the RFID tag will be attached to the social distancing alarm right here. This is what the smart device like. This is the smart device prototype. So as you can see here, if I scan my tag, this is the RFID will be at the entrance station. The RFID will be put in the station, then the smart device will be held by the passenger. So if I take my smart device that contains the RFID tag and I scan it, they will go to the database. The database will collect the date, time, RFID UID. RFID UID is unique for every tag. As you can see here, if I scan another RFID tag, then it will detect another RFID UID. In real life implementation, the RFID UID can be changed. Maybe it could be the name, contact number, etc. Depends on what the government needs to be stored in the RFID tag. The database that we're using is Microsoft Excel, I guess. Okay. Okay. Next, I will pass to my partner to explain about the COVID-19 checkpoint.
Okay, thank you. My name is Kang Xin-ji, and I'm going to explain about this COVID-19 checkpoint. First, there will be two 5-bit synchronous up counter, one set up at the entrance, while the other is set up at the exit. There will be a motion sensor at the exit and entrance. When they detect a person coming in or coming out, the counter will count 1. So to find the total people inside the vehicle, we are going to find the difference between this counter. To do that, we are going to connect the output of the counter at the entrance and the exit to adder. However, the output of the exit will take the Q bar, since we need to find the difference between them. Therefore, the output of the adder will be the total people on board on the vehicle. Then we'll show how many seats are still available in the vehicle by deduct the total people on board by the maximum limit capacity. In this case, the limit of the vehicle is set as 15. Therefore, the output of the third adder, which is the total seats are still available, will connect to a 7-segment display so that the passenger can know that are there still available places. Finally, we'll use a comparator to show a different situation. The first situation is when the temperature we measured is lower than 37.5, and then there are still available seats. Then the blue LED, which is in this case the LED 1, will be light up. The second condition is when there are no more places available, then the orange LED 2 will light up. Then when the temperature we detected is higher than 37.5, which is possible carrying the COVID-19 virus,
the red LED will light up to show danger. There are still one more LED connected at the second adder there, the yellow LED. That is because the limit we set is 15 people. Therefore, when this output, which is the fifth bit, the most significant bit, it shows that the limit is exceeded, and there is an error on this circuit. Okay, next. Here we'll show the results we get. Okay, play. Okay, when there are a counter, when the 7 segment display is display the total seats available, then the blue LED will light up. However, when the temperature detector is higher than 37.5, the red LED will light up. And then when the we'll wait at the 7 display, when it's count to 0, which shows no seats available, the orange LED will light up here. Then after that, the counter, if continue to count, it will exceed the limits. Therefore, the yellow LED will light up to show the error, and we need to reset it manually. Okay, next. In conclusion, the objective of this project to reduce the risk of virus COVID-19 to spread when using public transport is achieved. Because we can maintain the social distancing by ourselves is quite difficult, and we can use the system social distancing alarm to help us to warn when we are too close to each other. Then the AFID data collection system will also help us to track the origin of the virus at a short time. Next. During this mini project, there are some implementation challenges. When we are doing the circuit of the social distancing alarm, we lack some components and parts to build the prototype. As an example, we replace the buzzer with an LED. Then when we are doing the AFID data collection, the unstable AFID reader, sometimes it will have an error, and we need to try multiple times to get the result when it's the most stable. Then for the checkpoint, the Multisim didn't have the infrared motion sensor, therefore we replaced it by using a clock voltage source. Next. Okay, finally, this mini project for the future work can be enhanced by using a better sensor in terms of accuracy and sensitivity, and a better sensor with less delay time for the social distancing alarm. Then the AFID data collection, we can use a better secure database other than the Microsoft Excel. Finally, the checkpoint, we can upgrade the whole circuit to a better version because we have an error when the up counter reach its limit. Okay, next. That's all from you all. Thank you.
Okay, thank you, Jan and Shazwan. Okay, can we take 5 minutes break?
Okay.
Right. Okay, can we continue with group 4? Listen and Daniel, please.
Okay. Sir, can you hear me?
Yes.
Okay, thank you. So, good evening, Dr. Wan Ame Fuad Wajid Otman. My name is Fong Lik Singh and my teammate is Muhammad Daniel bin Muhammad Farizan. We are from EEM242 Group 4 and our title is Designing Smart Automation Home Door Sanitizer. An overview, this smart automation home door sanitizer is a fully automatic system, which this system can help us to get fully sanitized. Besides, this system also includes microprocessor and several sensors to complete the task needed. An introduction, the invention of the smart automation home door sanitizer is to avoid the spread of COVID-19 virus, which is one of our motivation to continue this project. And also we can get rid of the virus before we step into our house. And then this system also can help us to save a lot of time in order to get fully sanitized in just a few seconds. And then our objective is to design a smart automation home door sanitizer to design an electrical circuit which involves digital and analog parts, to determine the actuator which is suitable to open and close the door, and lastly to enhance the ability of using software in order to design the circuit. And methodology. First, we will get the team and then we will brainstorm with our teammates. After that, we will refer the Arduino codes and care maps to design a circuit. After design the circuit, we develop the circuit by using NI Multisim and also Proteus. If the circuit not run well, then we need to redo the circuit development. If the circuit run well, then we can continue with the writing report, record video, and presentation. And then the list of components. The components we use are the Arduino Uno, infrared sensor, sprayer, fingerprint sensor, electrical door lock, linear actuator, LED, buzzer, 7-segment relay module, and also several ICs. And the conceptual design, this is the front door, and this is the fingerprint sensor, and this is the door. And the back door, this is the linear actuator. If the linear actuator retract, it will pull the door and the door will open. If the linear actuator extend, it will push the door and then the door will close. And then this is a sprayer boom kit, which used to spray the sanitizer. And then this is the infrared sensor. It's used to detect the object. And then this is a schematic diagram. Because the software has some component do not have, so we use both software, which is the NI Multisim and Proteus. And then we also separate the circuit into several parts in order to explain clearer. So first is the Arduino Uno microprocessor circuit. The main component is the Arduino Uno, which used to receive and transfer signal. And then the first one is the fingerprint sensor, which we replace by the push button. And then the second until sixth part we replace by the LED. And then the second is the electrical door lock. Third is the relay module, which used to control the retraction and extension of the linear actuator in order to push and open and close the door. And then the fourth and fifth is the infrared sensor, is used to scan the object. And then the sixth is the input pulse to the counter if the condition needed for the counter to activate. This circuit has three conditions, and the condition we will discuss later in the result and the observation. And we also will upload video for the detailed explanation at YouTube for the Arduino Uno microprocessor circuit. So the second one is the relay module circuit. As I talk about, which the relay circuit is used to control the linear actuator, and the linear actuator will be replaced by the LED light. So let's see the stimulation. So first, when the both relay are high, there will no current flow through here. And also, if both the relay are low, there will also no current flow through here. What this mean is the linear actuator will not move, so the door will not move. And then let's continue. So if the first relay is high and then second relay is low, the current will flow from high to low, as shown in this bulb will light through. So the current flow from high to low, which indicate the linear actuator to extend. When the extension occur, this will cause the door to close. And then if the first relay is low, second relay is high, this will cause the current flow from low to high. This will cause the linear actuator to retract, and then the linear actuator will pull the door, and then the door will open. So the next one I will discuss about the down counter stopwatch indicator circuit. As I told before also, the input of the flip-flop is come from the Arduino if the condition needed. So the red LED light is used as an indicator to notice the owner do not come inside the room first, and then the green LED light is used to indicate the owner to come inside to the room. And then the blue circle is the input to the sprayer. And because the input only 5 volt, we will amplify it, but it will discuss later. And then let's see the stimulation. So this is the initial condition. When the inputs are transferred from Arduino to the counter, the timer will show 9, and then the red LED light will light up, which indicate the owner do not come in first. And then the counter will start to down count. And then once the counter reaches 7, the sprayer will start to function to sanitize the owner. Then the counter will continue to down count until the timer reaches 0. Once the timer reaches 0, the sprayer will stop function, and then the red LED light will turn off and green LED light will turn bright to notice the owner that the sanitizer process is done, and then he can come inside the room. After the owner leave the spraying area, the Arduino Uno will send the low input to the counter and cause all the flip-flop will be reset. And this will just happen in just a very short while, maybe 0 point something seconds. So the counter will be reset, and then the system can continue to run again. So right now, I will let my teammates to continue the presentation. Thank you.
Thank you, Lee Seng. Good evening to Doctor and my fellow friends. I am Daniel. Will continue the presentation. As we can see, the figure shows the schematic diagram for a non-inverting amplifier circuit to activate the sprayer and a water level sensor circuit. For the left side is a non-inverting amplifier with an off amp of LM741CH. The 5-volt voltage source is represent the input voltage of the OMs which came from the counter, while the voltmeter is used to measure the output voltage. The purpose of this non-inverting circuit is to amplify the 5-volt input which came from the counter to 12 volt in order to activate the sprayer, as the sprayer needed 12 volt to operate normally. Moving to the right side of the slide, which is a water level sensor. This water level sensor circuit is used to detect the level of the sanitizer. The LED in this circuit represent the buzzer of the water level sensor. When the LED lights up, it indicates that the buzzer was started to buzz, while when the LED did not light up, it indicates that the buzzer will not buzz. The normal close push button was used to replace the open circuit. When the liquid level was above the open circuit, the buzzer will not buzz since it will become short circuit. While when the liquid level was below the open circuit, the buzzer will buzz. The next slide is about result and observation. Next, please. There are 3 conditions that can be observed. The first condition is when the owner fingerprint unsuccessfully been detected by the fingerprint sensor. The system will not have an input, thus the system will not operate. The second condition is when the owner fingerprint successfully detected by the fingerprint sensor, but the owner do not step inside the door or still stay outside the door. For this condition, the door will open automatically, but after 5 seconds, it will close automatically and everything in the system will be reset, as the owner do not pass through the door and stand at the spring area. Next. The third condition is when the owner's fingerprint successfully detected by the fingerprint sensor and the owner step inside the door. For this condition, the door will open automatically, and after 5 seconds, the timer will start to count from 9. When the timer reaches 7, the sprayer will start to spray the sanitizer. When the timer reaches 0, the sprayer will stop functioning and the red LED will turn off while the green light will turn on. Lastly, after the owner leaves the spraying area, the door will close automatically and everything in the spray system will be reset. Next. From all of this, we can conclude that the smart automatic home door sanitizer successfully been designed. The circuit involved of digital and analog parts. Actuator used in the system have been determined, which is the linear actuator, and the ability of using software in order to design the circuit have been enhanced after going through this project. Next. The implementation challenging that we have faced are hard to have a discuss with our teammates through online, and the source of the system is limited, thus we need to spend more time to implement this circuit. The future works we can continue our work by enable to reopen the door if the owner suddenly pass through the door when the door is started to close. That's all from us. Thank you.
Thank you, Doctor.
Thank you, Group 4, Lisa and Daniel. Now we move to the final group, Group 2, Yilian and Danish, please.
Assalamualaikum and a very good evening to Dr. Wan Amir. I am Danish Amsha and my partner is Chong Yiliang. We are from Group 2 and our project is Smart Switch System. So for introduction, COVID-19 virus can be transmitted indirectly through a surface to person. Therefore, it is possible to get infected with COVID-19 virus through physical contact with any surfaces. Switches that are considered as a frequently touched surface which the place viruses hide. So the objective for this project is to reduce the risk of getting infected with COVID-19 virus through physical contact with the switches. And next is to reduce the dangers of having physical contact with the switches. Then to provide a more concise way in controlling the switches. Finally is to increase the energy efficiency. For the methodology, I will pass to my partner.
So I'm going to talk with this. Yes. So then just and like got the so okay. The the and then so we use this so uh, uh, the
So for the conclusion of our project is the smart switch circuit system is construct by using LDR sensor, field sensor, and also timer to provide a more convenient way in controlling the switch, so that during this COVID-19 epidemic, this switch system can help to reduce the risk of getting infected with COVID-19 virus through physical contact with the switches. So for our future work, we will add controller into the smart switch system circuit system, so that it can be controlled by using Bluetooth device or web-based control as in the progressive era of 21st century. A product of commanding is more preferable. It can explore and learn to use other simulation software such as Proteus and Arduino so that the function of the system can be well simulated or present. That is from our group. Thank you.
Okay, terima kasih. Thank you, Danish and Yilian. So, Alhamdulillah, for these 2 days we have here and completed 21 or 22 groups of presentation. So, secara dasarnya, in a way we can say that we can say that the objective of this mini project is achieved, has been achieved. So my comment, okay. So thank you all. So all of you, most of the group, all of you can present, can do a good presentation, can present and can manage to keep below 10 minutes time limit. And most of you, if not all, most of you can present and can discuss the figure and explain the figure and flowchart, the circuits well enough. But then I would like to stress that in your writing later on, please do not, because students tend to leave and tends to just paste the figures and tables onto the documents. But then students usually likes to ask or let the reader to guess what you meant by the figures and everything lah. So I would like to, again, before you submit your report, please explain and discuss your figures, your tables, your photo thoroughly, okay, as you present just now. Okay. One more thing before I forgot. Okay, I would like to stress this again. Your submission for the EEM242. Okay, EEM242, the assessment is on the presentation. We completed the presentation, then the demo, the Viva, and also the video. The video is not stated there. Anyway, so for your submission, you have to submit one file, only one file which is you already archive it using it's either zip, you can use zip or RAR, and you name it your file, the zip file or RAR file as this naming convention, EEM242 dash your group number dot zip ataupun RAR. So here are the what you need to have in your folder. So inside the main folder will be your group number, and then inside your group number, inside that group number folder, for example, if you are group 1 and your main folder will be group 1. Inside the group 1, then you will have the following folders name. Okay. So for example, here we have the proposal, progress, final, presentation slides, videos, sequence, photos, and photos of the team. So for the proposal, this here should be PPT ataupun PPTX. Okay, pardon my mistake here. So this is not compulsory, but you already have it. Then please attach it lah. So then you have the progress. The progress is also not compulsory. It's just an option because most of you have this, right? The progress, and might as well just keep it together. And then inside your final is a final, your EEM. Please follow this naming convention. Okay, so final, the doc format and also the PDF format, the presentation slides, the one that you show just now in PPTX and also the PDF. And the video EEM242, you should upload your video onto the YouTube, and in the video folder you'll be having this file name, text file. Okay, EM group number video URL dot text txt. So inside that you just paste your YouTube videos URL, and then inside the photo sequence you can give the photos of your whatever photos or picture or figures you have in your document, in your presentation, in your final, in your progress, also in proposal, whatever you have it, then you keep it in the photo sequence, the drawings. If you have the physical system, then the photos of the physical system in action is should be space here. Okay, in action etc. So last but not least, the photos of your team lah, the photos of the team, each person. And then you inside that you archive it ataupun you compress it using zip or RAW archiving software. Then you upload later onto the e-learn. So later on tomorrow afternoon I will open the submission link, and the submission will be closed by 6 o'clock on Friday. Should be Friday, 20th, even though it's stated here 20th. Yeah, it's here, right? 22nd January. So the submission will be on the latest by 6 o'clock Friday. Okay, I think that's it from me. Do you have any concern, any questions you might ask before we conclude this session? Dr. Pote, is it both PDF and Words also need? Yes, both. In Docs and PDF. Both formatting. Okay. Any more concern? Ada lagi? Any more concern? One. Any more concern? Any more question? Two. Then any more question? Any more concern? Three. So kalau tak ada apa-apa, I think that's it for today and this semester. Apa ni? For photo sequence. What is for photo sequence? Tam Yi Yang asking photo sequence, flow chart. Yes, everything in the whatever photos you have, except your teams. The team's photo of you is inside the team photo. Any other figures, flowcharts, drawing must be inside the photo sequence folder. If you don't have any photo, just ignore. Yes, just ignore. But you should have your photo, right? Photo of figures, right? For the you must have at least flow charts, your circuits, your drawing, right? Kalau tak ada photo of physical system, then just ignore the photo physical system. Put any figures, photos, flowcharts, drawings into the photo sequence folder. Boleh? Any more concern? The presentation slide, including the demonstration video, is needed. Okay, the demonstration video, if it's different from the video that you're going to upload, then it must be there lah. Okay. Or no video needed in the PPT. It's up to you, because you also need to upload the video documentation, right? But if it's already there, then might as well you just zip it or compress it and upload it. Boleh? Any more question? Any more concern? Any more concern? 1 and 2, documentation. That's mean video, if video documentation and video documentation is different, we need to do the text file for both. Inside one text file, you can point your video URL into the video URL file. Yes, with 2 links. Okay, boleh? Does the YouTube video need to be set to public or is it just can be set to private? Might as well set it to public. And remember when you upload it and there's a location there, set to Universiti Sains Malaysia Engineering Campus. If you upload your video, then you can tag the location. And the location, please tag to Universiti Sains Malaysia Engineering Campus. Alright. If coding also need to include the photo sequence, no, coding no need. Tak perlu set, tak perlu include your, do not need to include your coding. Okay. Ada lagi? Is there any more concern? The video we insert in the slide also need to upload to the YouTube. That one is up to you. Kalau if you upload it onto the YouTube, then you will be having a second link inside the video URL file, video URL document. Okay. Okay, faham? So the videos where you inserted into your slides, you can upload onto the YouTube. But if you upload it onto the YouTube, please supply also the URL for that particular video. Alright. Any more concern? 1. Any more concern? 2. Any more concern? 3. You are second year student, right? Okay. So for YouTube video location set to engineering, yes. For YouTube, you can tag the location to Universiti Sains Malaysia Engineering Campus. Okay. Any more concern? 1. Any more concern? 2. Any more concern? 3. So kalau tak ada apa-apa, then see you next semester. Next semester you will be seeing me in EEM242 Dynamics and Mechanism. Alright. Okay, I think that's all for today. Thank you for your attention. Thank you for your participation and thank you for your attendance. Okay, Assalamualaikum warahmatullahi.